Hi, my name is Matthias Herberner. I'm in Math 2000 in the Challenge program. And so today I'm going to be working two problems from the Thomas Calculus book. The first one is 5.4, from section 5.4, number 32, and it is to find the integral from 0 to 1 over the square root of 3 of dx over 1 plus 4x squared. Now this might look kind of familiar, and that's because it sort of is. If you remember, the derivative of the inverse tangent or arctan function is equal to 1 over 1 plus x squared. So you can kind of manipulate this to be 1 from 0 to 1 over root 3 of dx over 1 plus 2x squared. And now it's in the same form as this is. And so you would think that the antiderivative of this is just tangent of 2x, but it's not quite because of the chain rule. So you need to multiply it by 2 up here, and then that takes care of the chain rule. And to balance that out, you multiply it by 1/2 out in front. So now you have this, and that's easy to integrate. So you just take that and you get 1/2 of a tangent inverse of x tangent inverse of 2x from 0 to 1 over root 3. So then if you evaluate that, you get the inverse tangent of 2 over root 3 over 2 minus the inverse tangent of 0 over 2. And tangent of 0 is 0, so this is just going to go to 0. So we're left with this right here. But you really can't do anything with that. And if we want to make this a proper fraction so that it looks pretty, you just got to rationalize the denominator and do the same to the numerator, and you're left in the end with the tangent inverse of 2 times the square root of 3 over 3 all over 2. And so that's the integral of that. Okay, and so now the second problem is section 5.6, number 101, and it is to find the area. It's graphic, or it's a problem that can be solved graphically. It's to find the area between y equals 2x over 1 plus x squared and the x-axis from -2 is less than or equal to x is less than or equal to 2. So if you were to graph this function, which isn't that easy, you see that it's something like this, right? It's kind of like a straight and then curve and straight. It looks a little bit like the cubic function, but anyway, so this function is supposed to be symmetric. That is to say, if you rotate it 180 degrees about the origin, then it will be the exact same. So this is the same as that. And so if we're looking for it from, we'll say that that's -2, and that's x equals 2, right? So the area that we're looking for is this part and this part. So that's two sections. However, since the function is symmetric about the origin, this shape is the exact same as this shape, just rotated upside down. And since these distances are the same, these areas are going to be the same. However, since this is below the x-axis, it's going to return a negative value when you take the integral. And since this is going to return a positive value, and they are the same value, they will cancel each other out and get 0. But that's not an area. So what you're going to have to do is, so you take the integral from -2 to 2 of 2x over 1 plus x squared dx, and then you have to split it up into two integrals. So the left side of this is going to be -2 to 0 of 2x plus 1x squared dx, or 2x, and then you add to that from 0 to 2 of 2x over 1 plus x squared dx. Now, so if you remember, this from -2 to 0 is going to be the negative area, so to speak, even though such a thing doesn't really exist. So what you're going to need to do is put an absolute value around that. So then from this point on, it's just a straight shot. So you integrate that. 2x is the derivative of 1 plus x squared. So that satisfies the chain rule, and so you will get, if you integrate this, you get natural log, or well, the absolute value of the natural log of 1 plus x squared from -2 to 0. And then this second part is going to give you the same antiderivative, so it's going to be natural log of 1 plus x squared from 0 to 2. And now if you solve this, you'll get over here natural log of 1 plus 0 squared. Now this is going to be 0, so this is all going to be equal to 1. And the natural log of 1 is 0, so that's just going to be 0. And then minus, remember the absolute value, minus the natural log of 1 plus -2 squared. So now -2 squared is 4, plus 1 is 5. And so here you're going to get the negative natural log of 5. But the absolute value cancels it out, so just have the positive natural log of 5. So then over here, you're going to get the natural log of 1 plus 2 squared. Right, that's going to be 2 squared is 4, plus 1 is 5, so you're going to have another natural log of 5. Excuse me. And then you're going to have minus the natural log of 1 plus 0 squared, same as over here, that's going to go to 0. So you have the natural log of 5 plus the natural log of 5, which is the same as 2 times the natural log of 5. And we can use our logarithm rules to, I guess, simplify this further. Remember, when you multiply a logarithm, it's the same as raising the